Hello guys! Hello everybody! Welcome back to my YT channel. And at this point in time, we will be able to have a summary of our topic called as transport phenomena. Okay, latents like that, the driving force, the corresponding scientific laws involved, like that, the units, like that. So we are already have various regarding. Okay, I introduce problems of momentum transfer and flow and fluid mechanics, right? Okay, do you still remember for that? So actually, we're done, right? And we'll be able to shift to another topic, right? It's gonna be like that. And we will be dealing with that. Okay, but still we have to enumerate what are those. For example, extraction, absorption, adsorption, leaching, flotation, sedimentation, centrifugation, crystallization, drying, evaporation, condensation, sublimation, okay, deposition, solidification, and a lot of processes involved, okay, like that. Get the point? Okay. Now we will be able to write it down in a blank sheet of paper, the summary for this. So if you encounter like this in problem solving, then you can easily use this formulas and equations and think of the scientists also involved in this particular formula. So it's very clear now. So I have here a blank sheet of paper. I don't have problems for now, but we have only to, we're going to summarize. Okay? So, okay guys, I'll be able to have my, where's my, this one? I have to list it down here. Oh my god, wait. I have a lot of pentel pens, right? Then I have a little extra this chair here. God. Okay. Oh, what's this? Oh, really? Okay. Do we need a ruler for this or not? Oh, by the way, we don't need that one, right? Okay. So we start with the flux, Flux. So flux. Oh no, we start with the type of transport phenomenon. Phenomenon, right? It's not phenomenon, phenomenon. Okay. Like that. So we have here, oh my god, transport phenomenon, because it's singular phenomenon. The three are transport phenomena like that, okay? So this is general, like this. Okay? The next column will be our, just like making a table in your work, right? Using your Excel sheet and shall we say a Word format, okay? Like that. So we have flux here, flux, the second column. You guys, what do you mean by flux again? Flux is equal to the rate of transfer over area. Rate of transfer could either be momentum transfer, heat transfer, or mass transfer in the numerator. And in the denominator will be your area, could either be a surface area also and a cross-sectional area. It depends on the geometrical shape that you are considering somewhere along the way of your types or type of problem to be solved. Okay? So this is flux. So always think of it, there's an area in the denominator. Okay? And then we have the rate. So we will be saying, guys, that the flux version and the rate version. When you talk about the rate version, just listening, right? We have our own version, how to sing the song, like that. So rate version, first of all, rate transfer rate flow, rate of heat transfer flow. You know, because the flux is another story. There's still area in the denominator. Okay, so the flux is another thing. Meaning to say the rate is the more simplified equation compared to the flux. You get a point? Something like that. Okay. Rate. And then we're gonna have a driving force. Okay. It's very important to note the driving force of our transport phenomenon. For example, momentum transfer, what is the driving force? Okay, so our driving force will be the velocity. Okay, the velocity of the flow of the liquid or the fluid or a gas. Okay, so this is driving force. Okay, the third one will be the specific unit involved in the fifth column. Okay, this one. And the last column will be the scientific law that involves here, meaning the scientists who have a great contribution why this particular heat transfer exists and discovered. Okay, like that's a scientific law. None. Or scientific research by a certain scientist, something like that, okay? Or theory. You can have scientific law or theory, right? None. Then, ganun siya. Okay. Diba? Tabulation. So in tabulation, we can easily obtain the more basic equation and formulas we can easily, memorize, and we can see clearly. So we can compare. So this might be a comparative, study between the three, and then you can easily use it, something like that. So it's easy for us to remember if we will summarize it in a form of a table or something like that. Get the point? Okay. So I need to change my pentel pen because it's not clear. Oh my gosh. Okay, number one, momentum. Oh my gosh. It's clear or not? Yeah, it's clear. Momentum. So this is momentum transfer. Okay. This one, momentum transfer. This one is number one. Okay. So when we deal of momentum, basically that is the mass of an object multiplied to its velocity. So mass times velocity. So it's gonna be, the unit is kilogram meter per second. Okay. So this is related also to impulse, which is force times time. Okay. Like that. Get a point? So Newton second, right? And you have to convert that one, so it will be related also to momentum. Okay, conversion factor. Okay, because it's very, very useful to relate the two because the units are almost similar. Okay, since we know that Newton is equal to kilogram meter per second squared, then there is also kilogram in the unit of momentum. Then we can easily connect the two. Okay, something like that. But we are not dealing here with impulse. We are dealing here most of the times in momentum transfer where the change in the velocity gradients of the moving fluid, something like that. Okay? So it's gonna be like, I will illustrate this one. So this is the y-axis. Okay, y-axis, and this is an x-axis. Okay, The x-axis, guys, is normally represented as L, or the length, in the horizontal axis. So don't be confused that some books are using L, some books are using X, some books are using Z. Okay, but it has the same meaning, that it's a horizontal direction where your fluid and liquid flows. So this is the axis, y-axis, and x-axis. So our velocity profile will look like this. Velocity profile meaning each corresponding velocity that the fluid travels from surface to surface, from the surface down below, and then going up, going up, going up, going up, going up, like that. Okay, so it looks like it will produce a curve graph like that. Okay, so it's gonna be like this. Okay, then in the surface, guys, here for example, there's a zero, like this. So this is the velocity profile. Okay, like this. When the, it's layer by layer. Okay, so it's gonna be like that. The arrow is pointing to the x-axis like that, and this is the velocity like that. So this is the velocity profile. Okay, so take note at the surface of the, shall we say, a ground level, or shall we say a floor, like that, or shall we say a surface of a tank down below. Okay, so this is gonna be, it has a zero velocity profile, meaning to say this is called what we call as no slip boundary. Okay, this theory is no slip boundary because at this point in time there will be no slip of the fluid to flow. Okay, so meaning to say there's a very, 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 very strong resistance and viscosity at the floor or the ground surface. Okay, something like that compared to the, it when it will goes up at a higher level. Okay, so the resistance are very strong. Okay, so it's gonna be like that. So this is Vx1, Vx2, Vx3, Vx4. It's gonna be like that. So this is the corresponding velocity profile. Oh my gosh. Diba? Ganun, guys. I'm gonna show you drawing sa momentum transfer. Now our flux, we are in the second column here. So we will say that this is momentum flux. Because we're saying flux, so momentum flux. Okay, momentum flux. So momentum flux represented as, okay, this is equal also to shear stress. Okay, you might wonder why. Why is Sotero this is a shear stress? Okay, because this is also applying the Newton's law of viscosity. Okay, in parallel and in relation to the second law of Newton. Okay, this is the foundation of the fluid flow and fluid mechanics, obeying the Newton's law of viscosity, because for the fact that all fluids and liquids will always have a certain resistance to flow of fluid, which is known as the viscosity. So if we try to incorporate the resistance, Newton's law of viscosity will be applied there. Okay, as a theory, then we can also, correlate the second law of Newton, which is the law of acceleration. Why? Because the water also, or the fluid, will accelerate with its corresponding velocity and speed. Okay? So automatically, there must be an acceleration in a horizontal acceleration. By the way, class, this is not applicable in a downward, movement. This is only applicable in the horizontal movement, fluid flow. Okay? Could either be going backward, going forward, but never going downward. Okay, or else gravity will be there. So it's another story. Okay, so it will obey now the third law of Isaac Newton and the gravity thing. Okay, so when can we connect the gravity thing? So it's also in the equation of the centripetal force, like that. Okay? So force is equals to mv squared over r, where v is the velocity. We can use that one also, especially if our tank and vessels are round shaped in the opening. But okay, we will not use this downward, always horizontal. Okay, let's agree. Okay, because there's a lot of movement downward, upward, left to the right. Okay, ganun siya. So even if the flow will move to the west, like that, or no, not the west, north and south. Right? Okay. It's gonna be the 45 degrees. It's also applied as long as it will never go up with certain angle of inclination. It's okay. For example, 26% angle of inclination where the fluid moves. It's still applicable and covered in momentum transfer. But what I mean is the 90 degrees moving up and moving down. It's not applied here. The momentum transfer. Okay? Get the point? So in that manner, viscosity will not affect. Okay? Because the more you drop an object, okay, the resistance is not strong. It will become zero due to the weight of the object being dropped. Okay? So it's gonna be like that, right? So what matters there is the gravitational pull of the earth or the gravitational force. Okay? So that's why it's not applied here. Ha? Giklaro na ako. Okay. Now, momentum flux. What is the designation we have? Since this is momentum, guys, I told you momentum is a shear stress also, right? So in this manner, we need to think of as pressure is equal to force over area. And pressure, guys, don't be confused. Pressure really is a shear stress. Okay? It has the same meaning. Okay? And unit. So don't be confused. Someday in selection problem, we'll say, what is the shear stress of this following if we applied a 15 Newton of force like that in a rectangular surface area? And then you don't know how to answer that because you are always dependent on the word pressure. Okay, so problem, you cannot answer. Actually, that is also pressure. Okay, shear stress is equals to pressure. That's why it has the same unit. Get a point? It is kilogram per square meter. Like that. Yes, kilogram square per meter. That's why we have pounds per square inch, PSI. Meaning, the numerator is always a mass. Okay, and denominator, like that, it's length raised to the power 2. Corresponds to a surface area or a cross-sectional area. Something like that. Okay, now, I will put here, we will connect the physics here really in studying this momentum transfer. Okay, so momentum flux. I'm just explaining before putting to the second column, okay? Like that. And then pressure is force over area. Okay. Now guys, since we are dealing here with momentum transfer, okay, so P will become now the tau. Tau, like this. Tau represents shear stress. So we will change this to tau. Okay, tau, symbol. Tau, like, dili tau nga po ang human being, tau, symbol. Okay? Like that. So tau is equals to force. Instead of saying force, this will now become viscous force. Okay, so carrying the adjective because this type of force are having viscosity. Okay, so that's why it's called viscous force. Okay, to specify in this kind of formula. But we are only using the same formula, the principal formula or the core formula. Okay, this is viscous force. Okay, because this is for fluid and liquid. This is not for solid. This is not for solid. Na imong gi-push ang mga kuan, object. Okay, it's not like that, okay? So, viscous force is equals to area. So, meaning to say, viscous force is equals to tau times area. This one. So, viscous force is equals to tau times area. Oh my gosh. Viscous force is equal to tau times area. From the formula, pressure is equal to force per area. Since you know that the pressure is equal to the shear stress. Okay, like this. Now, this is very important because this is very important in the Reynolds number computation. You get the point? So this is very important so that we can easily distinguish if the flow of the fluid, okay, and a liquid and a gas is really laminar steady state flow or unsteady state flow which is turbulent. Okay, so this is the basic for the fluid form. So we need to understand for this. Okay, so that's why it's very useful the Reynolds number for the flow of fluid. So the Reynolds number, I'm just correlating because usually in momentum transfer this is really the problem to be most of the times are coming out in the examination or in the board examination. It's always like that. What is the kind of flow? Like that, okay? And then we should remember also that below 2100 is a laminar flow and above 2100 is a turbulent flow. So we will say that it's a turbulent flow because it will develop an EDs, ADDIES. When the fluid moves, there's a lot of EDs, meaning a random motion of those molecules in a zigzag situation or orientation, or erratic, meaning there's no permanent movement of those molecules, so it's called turbulent, magulo siya, something like that. Okay, whereas laminar is steady state, so it's like a uniform one line or singular flow, very small flow only, like that. Okay, so like that. So if there's no EDDY, and plural is EDs, that is not a turbulent flow. Because sometimes also in theory questions, what is an identification of a turbulent flow? Like that. And there's a multiple choice there. Like that. Your answer will be a formation of EDs. ADDIES. Okay, that's an identification that a turbulent flow exists already in your flow of fluid. Okay, get the point? And applying the Newton's law of viscosity. Now, so we have the Reynolds number. Very important here, guys. How can we achieve the velocity profile if we don't know the Reynolds number? So we need to distinguish first the flow, the type of flow, right? Of course. Okay, so Reynolds number is equal to. This is only a review. Okay, so that we will understand clearly. Okay, so Reynolds number is equal to the inertial force. Okay, over the viscous force. Okay, viscous force. This one. Guys, inertial force, guys, this is a type of force that an object will continue moving. For example, I will push the chair horizontally. This chair will continuously moving unless acted upon by a net force. So this is a law of inertia. Okay, the first law of Newton, Isaac Newton. Whenever an object in motion will continue move unless acted upon by a net force, like that. So it will continue moving unless it will be stopped by a resistance to flow, something like that, or a fraction. Okay, so but in here, inertial force is also tricky, right? You say, oh my gosh, inertial force, I think it's gonna prefer slow, but actually this is the second law. Okay, this is the force. The inertial force we mean here is the acceleration, which is mass times acceleration, or the force is equal to mass times acceleration. Okay, guys? Ganun siya. So, mass times acceleration. And viscous force, kaya ito naman na-compute ang viscous force diri ari. So, we can say that viscous force equals to shear stress times area. Okay. Shear stress times area. We don't have to derive already because we memorized already the formula of Reynolds numbers. I'm just showing where it comes from. Okay, so that is very important. Where it originated, because it is not a magic. Okay, there's a reason behind why that formula arises or evolve, something like that. So there's really, the basic reason out of that. That's why we need to discuss a little bit. Where did it come from? Like, that is derivation. Okay, but I don't have to state the derivation here already because we did it already last how many weeks ago, Okay, but we will say this as ganun siya. So after the derivation, we can obtain as the density times the velocity times the length or thickness over the mu. So this is now our Reynolds number. Okay. Again, the Reynolds number is equal to the density times the velocity, okay, times the length or the thickness over the mu or the viscosity. Now, guys, what is this mu all about? Mu, just like a micro, right? The symbol. So this mu is confusing sometimes because there are three types of viscosity. We have the kinematic viscosity. You get a point? We have also the dynamic viscosity, and we have the absolute viscosity. So how can we determine this? Okay, because if you try to substitute one viscosity to another, there's a chance that you will be wrong. Okay, because there's a slight differences of the units, slight differences. Okay, so when you substitute that here, so you cannot obtain a unitless Reynolds number. Reynolds number is unitless, right? Okay, that's why 2100, then now there's no unit, okay? Like that. So it's gonna be like that. You got a point now? So nugget density, because it is a movement of the fluid to flow. How heavier or how lighter, like the liquid, the fluids and gases will flow to a certain medium. Okay? Okay, mo na nahitabo karon higayon na. Okay. Now, so momentum flux is equals to, so momentum flux will become, our definition will be rate of transfer over the area. So we will say d tau over dA. The derivative of a shear stress over the derivative of a surface area. So d tau dA is our flux. So put this in your brain cells. If you talk about flux, there's always have an area in the denominator. You get a point? So it matters a lot. Okay? Because if you solve the rate, there's no area in the denominator. So problem. Okay? So it will not agree to what is being asked. So be careful also with the terminology. So calculate the momentum flux of a certain blah 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 blah, so and so. Calculate the momentum rate flow. It's another story because the momentum rate flow has a time in the denominator. So I told you over 1 billion times. Rate has a time in the denominator. Okay, usually expressed in seconds. The standard in metric system, especially the acceleration and the velocity. Okay, like that, or the speed. Okay, guys, d tau over dA mo na siya ang flux. Now, ako sa buhatag formula ang flux, of course. So mo ni siya ang dynamic viscosity siya klasa, dili siya kinematic viscosity. Okay, again, dynamic viscosity times delta change in the velocity over the delta change in the length or the horizontal direction covered in this fluid as I illustrated here in the velocity profile. It's gonna be dx in here. Okay, because I don't put L, but actually it's just the same. Okay, the representation would not matter. The important is it's agree that this is the horizontal axis covered by your fluid during movement or during motion of your fluid and liquid and gases. It's gonna be dynamic viscosity mu. Again, momentum flux is equal to the dynamic viscosity mu times the delta change in velocity over the delta change in the horizontal axis, which is the x, and sometimes L also. Okay? Like that. You get the point? Now, if you try to solve for the momentum flux, very important to get the dynamic viscosity. And take note, this dynamic viscosity is our momentum diffusivity. Okay? Momentum diffusivity. Sa IGBOG, kalibog niya, ang higayon na that the dynamic viscosity is the momentum diffusivity. So it's very easy to detect also if we are going now to the heat transfer and the mass transfer, just put the type of transport phenomenon and then add that one. For example, momentum diffusivity, okay, heat transfer diffusivity, and then mass transfer diffusivity. And there are also another terms for that. For the momentum diffusivity, it's called momentum diffusion coefficient. Okay, again, another term for momentum diffusivity, momentum diffusion coefficient. Okay, another term for the heat transfer diffusivity is also thermal diffusivity. Thermal diffusivity. Okay, and another term also with the mass diffusivity is the diffusion coefficient. Diffusion coefficient, because the mass transfer is dealing with the Fick's law, first law of the diffusion specifically. So it's called diffusion coefficient. Actually, this we have diffusion. Special lang din ang mass transfer kay Mr. Fix. Okay, a scientist to discover this mass transfer through concentration gradient. Okay, something like that. Okay, now we go to the specific. Okay, I said well ago, momentum diffusivity, momentum diffusion coefficient. Now, the specific term for that is dynamic viscosity. Dynamic viscosity. So this theory can be used interchangeably in the problem solving. Since these three terms have, so all you have to do is to detect the unit, okay, so that you will be able to, oh, this is going to be the, and then you have to substitute there. Because if you don't have an idea, okay, so you should know the units. For example, if you don't have knowledge in the three terms I mentioned just now, which is the momentum diffusivity, momentum diffusion coefficient, and dynamic viscosity are just the same. So we will troubleshoot and determine the unit specifically so that we will not be confused. So what is the unit of dynamic viscosity? Diyan na naman tayo. Okay, the unit of dynamic viscosity is centimeters squared over second. Okay, it's gonna be like that when you talk about diffusion. It's gonna be the area over the time. Okay, so centimeters squared over second show to the fact that that is length raised to the power 2, because length over power 2 and meter raised to the power 2, or it will become an area already over the time, which is seconds. So area over second or area over time, so it becomes centimeters squared over second. Now, if you don't want that kind of unit, then you will be able to express that in terms of the scientist who discovered this dynamic viscosity, Chuba Chuchu. So it's gonna be the Navier-Stokes, Mr. Navier-Stokes. So Mr. Navier-Stokes discovered this kind of viscosity. So that's why we need to put his last name in this. So 1 centimeter squared per second is equal to 1 Stokes. Got a point? And it is also equal to 100 centi-Stokes. Remember always in the linear conversion factors in the length. For example, 100 centimeter is equals to 1 meter. It's just like a principle, so that you will never forget. Okay, the relation. For example, I say 100 centimeter. The word centi is very important. So the same as 100 centi-Stokes. And then 100 centi-Stokes is equals to 1 Stokes. Most at siya, 100 centimeter is equals to 1 meter, so that you can put that in your brain cells. You will never forget. So that's the value. So that is also equal to centimeters squared over second. So It's gonna be like that. Centimeter squared over second is equal to 1 stoke is equal to 100 centistoke, and this is our dynamic viscosity, momentum diffusion coefficient, and our momentum diffusion coefficient, and our momentum diffusivity. And I thank you. Muna siya ha. Okay, now we go now to the heat transfer later on. Okay, ato na siyang isuwat diri ari. Okay, nag-comparative study dito. We need to have comparative study ha. So this is very important also. Okay, we need to evaluate. Especially when you do a comparative study, what matters there's the most is the applicability, the effect to the environment, the effect or the impact to the human being. Could it be sustainable for a longer period of time when you use that one? So environmental friendly, and also it is really cost effective considering the financial aspects in your comparative study. So there's gonna be like that always. You compare, especially you do the quotation and you buy the equipment. For example, you buy a stationary equipment or whatever rotating equipment to be put in your plant industries or whatever in your factories, and you have to assess the cost, the quality, the environmental impact, and the sustainability, something like that. So for again, quality, cost, okay, environmental impact, something like that, and also the sustainability, something like that. Okay, then because if it is sustainable or if it is environmental friendly and it has a good effect to the people who will use that one, so that could mean safe. Okay, that's why I did not include safety. I said only cost effective, okay, quality, sustainable, like that, and cost. Because if it is sustainable and environmental friendly, that's already safe. Okay, how could it to sustain to how many years if it is not safe? So that's why I did not separate the safety there. Actually, safety is considered, okay, under environmental, something like that, or the effect to human being. Okay, you will assess that one and during your quotations and buying that equipment or raw materials or whatever. Okay, it's gonna be analyzed by the engineer, something like that. Okay, especially in the designing stage. Okay, you need to have your feasibility study. Okay, how to acquire those equipment, raw materials or technology. So it's gonna be the engineer will analyze, evaluate, and blah blah blah. Okay, of course, he will use the application of mathematics and science in understanding for that. Okay, like that. And the economics. Okay, economics is very important also. Okay, engineering economics. Okay, and equipment design, something like that. So, going back, saan naman ito kong formula? Uy, grabe ka Sir Jimmy, tabihan kayo ka, yes, of course. Charot! Okay, so d tau dA is equals to the mu over dV dx. This one, ano na itong flux? Momentum flux or shear stress. Ganon. Okay, it's very clear class. No objection so far. Okay. If you want to object, then comment down below in the comment section. Okay. Oh my gosh. Now the rate will be, guys, will be like this. I will show you how. Okay, this rate. The rate will be shear stress over the time because that's rate. Okay, so d tau is equals to dt. So this is rate. Okay, d tau dt meaning the change in the shear stress over the change in time. D meaning change. It's just like the same as delta. Putting small triangle. Okay, there's a change. Okay, so change in shear stress over change in time. So d tau over dt. Ganon. So now, because we have the momentum flux here, we do the algebra in the momentum flux. This is very important to note, guys, that there's an equality sign here. So the equality sign could mean a direct multiplication, crisscross multiplication. So it will now, I will show. Actually, this is very easy. I think this will discuss in high school. I think elementary level don't have this kind of discussion already. Okay, so d tau. So the basic operations are already discussed in high school, right? First year high school. Okay, so d tau over dA is equals to ganun siya, no? Mu over dV dx. Now, if we have the first cross multiplication, the area in the denominator will go to the, to the right. Right? Ano muna natin, x. The x is the direction where to multiply. Okay, so mahimo na siyang d tau dx. O mahimo din siyang mu dA dV. Ganun siya. Okay? You got the point? Muna tabo karong higayon na. So, pwede na sa Japan na dili mo siya i-carry ang dx as is lang siya because that is really the change in the velocity, in your velocity profile. It doesn't matter. Okay? Ganun siya. So, rate, muna na siya natabo. So, it will become d tau dt is equals to, okay, mo siyang i-multiply, it will become mu area dv dx. This one, mu area dv dx. You get the point? Ganun siya. Now, mu is your dynamic viscosity, right? In terms of centimeters squared over second. Now, we go to the kinematic viscosity. What is the role of the kinematic viscosity here? Okay, what is the rule of the kinematic viscosity here? The rule of the kinematic viscosity, because you cannot obtain the dynamic viscosity without the kinematic viscosity. Di ba makalibog siya? Good lang kasi if the problem will state directly the viscosity. So that's why I told you, you have to analyze. Because in the problem solving, the word there is reflected is only viscosity. It doesn't specify whether dynamic, absolute, and kinematic. And since there is a slight difference in unit, masayop pang ka. So we need to distinguish really the specific type of viscosity. Now be careful because this mu is the dynamic viscosity. This is not the kinematic viscosity. Now if you try to substitute that here in your momentum flux and in your rate of momentum, okay, there's a tendency you will be wrong. Okay? Because this dynamic viscosity is equal to the kinematic viscosity multiplied by the density. Okay, you get the point? So, dako kasi kalahian, di ba? You get the point? Because kung talk about kinematic viscosity, we need to multiply it with the density. But if we talk about dynamic viscosity, we don't multiply that with the density. So, wrong na kadaan. So, be careful in dealing with fluid mechanics and fluid flow. Okay lang yun siya kung ihatag na gidaan ng viscosity na maujud ang dynamic ba. For example, given the problem, 25 centimeter squared per second, like this. Automatic na siya nga dynamic viscosity. Kaya mo na yung unit. Okay? Even though wala siya specified. Now, if the unit of the viscosity shown there like this, the viscosity is 215 kilogram meter per second. Like that. And kilogram per meter per second is the kinematic viscosity baya. Di ba mo siya pwedeng ipugos dito sa dynamic viscosity. So, muagi sa kani nga formula, which is, okay, dynamic viscosity is equals to kinematic viscosity times the density. Okay? So, this is only expect the unexpected. Okay? Because normally naman sa siguro gyud siya, muhatag bigyo sila diretso nga dynamic viscosity. Okay? So that would be the usual cases. But what if they will give the kinematic viscosity nga? Okay, because it carries the density in the formula. So that's my point there. Okay, because not all the time will be like that. They will change like that, everything. That's why it is expect the unexpected in the future examinations. Okay, guys? That's why we maximize our study, maximize our learning and knowledge out from the box, out from the classroom instruction. We need to go out. Okay, we need to do a lot of study in our home, in our room, in our sala, like that, in our mini library. If you have mini library, or you can go to your institution or university library, that's meaning out of the box. Okay? So if you are dependent on in classroom instruction, nga jud ka. Okay? Because, not they cannot feed you the detail of a certain topic because only 1 hour and 2 hours subject it's not enough to extract all majority of the topics in a particular situation. For example, my subject is heat transfer. And then I give it only 1 hour. Just like that, I blog too much time, right? So just like that, I feed you too much. Okay, but in the actual studying in this curriculum, only 1 hour every day. Dili-dili alatul. Ganon. Okay, so it is expected na mo out siya sa of the backs and we go to the library in our own effort so that we can maximize our learning and knowledge for the particular topics, right? So as much as possible, you should be advanced. Okay? If the instructor is discussing that one and then you are advanced than him, you go to another topic. Really? Okay? Especially if you feel the topics are easy for you, then you read all and then go to another topic in your extra time so that you will just sit there and there's no more writing in the notebook. You got the point. Okay, and you will just bring 2 notebooks, 1 notebook. You will never write too much notebook, something like in the notebook. You're just sitting and you're listening like that, and then the instructor will ask you and you will answer like this because you study already, okay, and then advance. You get the point? But I think so. Not many students are doing this, okay, because it's very tasky. But if it is for your own improvement and for your own learning, okay, so you have to do that, okay, because nobody teaches you to do that, okay. Nobody teaches you to do that because instructors will never teach you the character, personality, and values how to study. They will go directly to the topic. Okay, did you meet an instructor telling it to do that? Right? She will never say, oh, you must go to like this number because it's understood already that you have to do that. Okay? Ganon siya ang mangyayari. Ganon. So, rate. Ang atong rate ni gayon na, pinanamatay niyo over dv over dx. Nasa tayo laing version. So, we have d, version give me. Okay, d tau over dt is equals to the dynamic viscosity or the momentum diffusion coefficient times the change in velocity over the horizontal movement of the fluid, like this. Muna siya itong another version. Okay, like this. Okay, now you need to incorporate the density and the kinematic viscosity now. So let's say kinematic viscosity is equals to dynamic viscosity over density. Okay, now if you try to compute for the dynamic viscosity, the dynamic viscosity is equals to the density times the kinematic viscosity. So substitute this kinematic viscosity multiplied with the density in your equation now. So it will become kinematic viscosity density times dv dx. So this is your another version of your momentum rate flow. This one. So duha ka version. Okay? The other in terms of area and the other in terms of the density. Okay? So magpili ra ka ana kung mga given dito sa problem na imo din siyang i-plug. Then ayaw pugsa kung nili jud agree ang mga units, then you have to convert like that, so and so. Okay? So equation 1, equation 2. But may go kita sa pinaka-common mo ni siya ang kinematic viscosity times density dv dx. Kalimti na sa tong area kaya ang area dili kay mo matter diri sa sa momentum flow. O sa fluid mechanics or sa fluid flow, guys, the area will not matter a lot. Okay, it's in the mass transfer and in the heat transfer that the area will matter a lot. Then there also, the density will not matter. a lot. Okay? Baliktad siya, di ba? And then, sometimes also, the density matters because sometimes there will be no given in the concentration. Mo na ay imong kon mag-drive na ka, imo ipang kunik-kunik man sa imong brain cells. Ana ra man uy. Ana ra jud siya. Di ba? To those who can relate, mo jud na siya. Mo bitaw ko ninyo na an engineer should have a wild imagination. Because there's a lot of possibilities, wrapping in your cerebral part of your brain cells. Cerebral compartment in which the memory retains. That is a portion or a region where the memory stuck and retained. That is a cerebral part of your brain. Okay? Ganon. So, urot ako mga kuan, fairness. So, I have to put now in the third column. Here. Di ba guys? So ako iput ang katong kinematic viscosity times density. Okay. Mo-focus ta what is very common in doing the comparative study, not on the, tuki part. Okay, in the basic lang talaga siya. Okay, when we deal the comparative. Okay? Like this. For easy understanding comprehension, we go to the most popular and widely known used equation and formulas. Okay? So it's gonna be like this. So d tau, okay, d tau dt is equal to the kinematic viscosity times the density times the dv dx. Okay, dv dx. V here is the velocity gradient ha. This is not the volume. That's why I put small letter to signify that this is the volume, this is the velocity, not the volume. Sorry. Okay? So, let's agree. Capital V is the volume. Small letter v is the velocity. Okay. Now, let's go now to the fourth column, our driving force. Our driving force will be the velocity gradient. Okay, the movement of the higher velocity at point A to the movement of the lower velocity point B. It always like that, starting from a higher velocity to the lower velocity. And then this movement's referring to the molecules. Okay, molecules of the fluid and atom. Now it's in here also na we should remember also the relationship between the number of moles, the mass, like that, okay, the volume, the pressure, okay, something like that, so that you can really understand what's going on when the fluid and liquid will move, and the density also. You get the point? Like this. And then that is also the time that we need to account the mass flow rate, molar flow rate, material balance, overall material balance, component balance, energy balance, and then the most popular and widely used equation in momentum transfer, the Bernoulli Equation. Okay, take a Bernoulli Equation is the only equation used in the design of jet, airplane, missiles in the outer space. If you don't know about Bernoulli Equation, this is all about energy, you will never come up with the design of this particular, missiles, okay, airplane, jet, because this involves a very, 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 very infinite energy, immeasurable, boundless, immeasurable, meaning infinite. So you will be dealing a huge of energies for this, and the only equation that produces energies are the Bernoulli Equation. Nothing else. Okay, this is very important in BS Aeronautical Engineering. Okay, they will be dealing on first year college pa lang, nag-Bernoulli na talaga sila. Okay, because this is applying velocity in order airplane to move out to the sky. So we need a high energy for that. How can the airplane will go to the sky if there's no energy? Okay, so they have to study the equation of Bernoulli theorem, Bernoulli equation. Of course, nowadays we are advanced. They will be using the computer to do that. Not the manual computation like this, but what I mean, the principles and theories used are Bernoulli theorem, Bernoulli equation. Of course, if we don't know how to understand the basics, then how can you manipulate the computer if you don't know how the basics formulas for that? Okay, so you need to know the Bernoulli equation like that. Not only that, also for the nuclear engineering. Nuclear engineering. Okay, so they are also having that kind of study for Bernoulli equation. Of course, we chemical engineers also know that, but if you talk about time and space in the universe, outer space, so it's gonna be like the aeronautical engineering is a lot, better than this. Okay? Mga flow pa. Okay, like that. Or movement. Chung! Chung! Ganon. I-compute din mo mga kuan. Chupa-chucho. Okay? Okay, mo na siya huge energies dito napita. Dili kasi yung mga kuan naman siya mga liquid, gases, ganun lang siya. Okay. So, but yung grabe na yun. Okay? So, driving force will be the velocity gradient. So, I will say velocity gradient and gradient, guys, is just difference or change. Velocity change, velocity gradient, and velocity difference is just the same. Okay? Don't be afraid with the terminology, something like that. So velocity gradient. Okay? Velocity gradient. So this is our driving force. Okay? Ganon. Then guys, if you want to learn about another equations for the, fluid flow or momentum transfer, you have to learn also the Euler equation, Euler equation, Navier-Stokes equation, Bernoulli equation, Newton's law of viscosity. Because maugin siyang upat magtuyok rin siya. But since Bernoulli equation and then the Reynolds number like that is very easy to understand because it is linear. You know linear? Linear algebraic expression. Don't have calculus thing. So this is very easy. But this Navier-Stokes equation and Euler equation also can be used, but there's a lot of chuba-chuchu. Okay, differential equation, limits from blah 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 to blah blah blah, and then normally only engineers can understand that well. But for common understanding, another courses they cannot understand. So it's better to use the algebraic expression, the linear expression, which is only the basic mathematics or the algebra thing. Okay, not the calculus. You get a point? Because it involves differential equation in combination with differential and integral. Really, if you see, guys, dt dx, the d there is understood to be a derivative. So meaning to say, if we try to use the differential equation and the differential calculus, it can be used. Okay, since our limit is just very simple to understand, that's why we use algebra. First one, dv, derivative of the volume. So it's just the same as v2 minus v1. So why should I use the differentiation wherein I can only subtract from the final volume to the initial volume? So that's it, right? Okay, but if you will study those specific subject, then you have to, because there is also subject for that. You have to pass. That's the purpose, only to pass that subject. Okay, but in reality, you don't have to calculate in differential and integral when you graduate. Okay, we are working now in the field. So of course, if your job is need designing, then you have to incorporate that during designing stage, because there will be differential calculus also in designing stage of your equipment, your machine. But what I'm talking, if you are not on the designing job, okay, then this calculus thing will never use. Okay, it's always the algebra, geometry, trigonometry, and a simple operation: plus, subtract, multiplication, division, ratio, and proportion. Well, I told you ratio and proportion is very important also, because if you're given, for example, if you're given a water hose, and there's a big diameter hose, and there's another diameter hose, then you need to compute what the distance this hose to cover during, if you try to, spray that, or if you try to run that to the higher level, you need to do the ratio and proportion so that we can check what is the elevation for this another type of hose. Okay, hose 1 is equals to hose 2. Ganon. Diameter 1 over diameter 2. Ganon. So you can, in that, you can really compute what is being required in actual na talaga siya. So that's why ma-apply pa gyapon ang algebra. Okay, but we cannot apply the calculus thing na talaga siya in actual. Okay? Simple na may tabo. For example, salary. Salary coming, you will integrate? You will differentiate? No. You got the point? When you go to the market, when you go to the mall and you buy a product, you have to integrate the price. You have to differentiate the price. Oh, I need to get the limits so that I can pay the amount of this product. No, no need, right? It's only you have to multiply, you have to divide. You have to. So for practicality purpose, the best really is you have a basic foundation and learning for algebra and geometry and a little bit of trigonometry. Kana lang siya daog na gyud siya daan. Okay? Get the point? Ganun siya. Unless you'll be able to take masteral study. Okay, but enough naman siya kung ano siya simple mathematics na siya ba? Okay. Now, unit ani niyang kuan. Unsa may unit ani niya? Nakaloka. Unit. So this is gonna be stress. Okay, kilogram meter squared like that. Kilogram meter squared. Okay. Second. So it's gonna be kilogram meter second. As you can observe, guys, kilogram per meter per second is just also the unit of the mass flow rate. Right? You get the point? So, literally, we have the same unit. Because it's a stress, d stress over dt. T in the denominator is S, and the numerator is pressure, kilogram per square meter is a unit of pressure man gid siya. Okay? So, playing somewhere along the way, it will become kilogram per square meter seconds, which is also the mass flow rate thing in the mass transfer. So, in order to be unique, we need to convert this to Newton. We can do this by Newton also. But we cannot, because the second in the denominator is not raised to the power 2. So, we cannot force this to Newton. You get the point? Okay, we can have this in a volumetric flow rate also by accounting the density. But we are dealing with a shear stress, man. Okay, so no need. No need to expand further. Just limit with a kilogram meters per second, something like that. Because it's the unit for your momentum transfer. Am I correct? Okay, ganun siya. You get the point? And our scientific law involved here, guys, is the Newton's law of viscosity. So, N, capital L, capital V. So, Newton's law of viscosity. Ganon. Because in the theory questions also, if you are taking the examination in the future, for example, board examination, so it cannot be denied. Sometimes it will come out in the theory, something like that. Blanc is a scientific theory that used in momentum transfer, and there's a lot of law there. Okay, Dalton's law, B, ideal gas law, C, ganun siya, Max Planck law, D, Newton's law of viscosity. So your answer will be Newton's law of viscosity. That's my purpose here, why I'm trying to teach you about theories. Okay, because it's not all problem solving in the examination. There's a balancing there. Okay? So kung may kitang problem solving, mabitag ka sa theory, wala. Nga. Okay? So be careful also. You need to have balance. Both theories and problem solving. Okay? In equilibrium. Just like balancing the chemical reaction. You should balance the forward rate of reaction and the backward rate of the reaction, the reactant and the product, so that you can stabilize your stoichiometric relationships, something like that, in order for you to solve what is being required in that particular balanced chemical reaction. So you need to be balanced. So balancing every time gina siya balance. Okay? For example, also in human beings should be balanced spiritually, mentally, physically, socially, emotionally. So being the component of a human being, you'll also be balanced. So just like the same also in a chemical reaction, just like also in taking examination. Right? Balance is the key term there. Okay, if there's balance, then there will be no chaos. Chaos. C-H-A-O-S. Okay? There will be no conflict if there's balance. I think so, right? Because if there's balance, there's neutralization between, shall we say, agreeing to some points and disagreeing to some points, and between a conflict, argument, because there's balance, there's neutral, right? So balancing out of the equation is very important. Okay? In this, world. World talaga. Okay? So Newton's law of viscosity, NLV, is the scientific theory for the momentum transfer. Mo na ni siya. Now guys, this detailed momentum rate flow or momentum rate transfer, this is now the Newton's law of viscosity equation. Kani siyang na ay kinematic viscosity, density, velocity over dx. Okay guys? Ganun na siya ha. So yun naman ang kaya na siya kay dv, v2 minus v1, niya ang x, x2 minus x1 sa horizontal. Kamu na bahala niya anang higayon na to analyze in the problem solving. So muna na siya ang Newton's law of viscosity. In equation so far, imagine I'll just deal with momentum transfer. It took me 1 hour to finish. Okay? And there's still heat transfer and mass transfer. Oh my gosh. The summary looks like very lengthy, right? Because I tried to discuss in a detailed fashion. Charot. Or in a spoon-feed manner. Okay? Ganun siya. So, nanatay momentum transfer. Wait, kuan sa kong, mayroon sa kukuan ini tubig. So, I'll be back for the summary of the heat transfer, right? I'll just cut it off this live streaming and I'll come back, right? And I have to take also my dinner. What time now? Oh my gosh. My dinner is just very simple because I don't eat rice. Okay? So I don't eat rice, so it's easy for me to manage. And, like that. Okay guys, I have to cut it off this one. I will be going later to the heat transfer. If you like this, video, comment down below in the comment section. If you're not subscribing to my channel, then you can subscribe. Guys, thank you so much. God bless. Bye bye everybody. See you later in my heat transfer summary and comparative analysis with other heat transfer phenomena. Okay, thank you. Bye bye. Guys, kaloka. Diba?